Hello there, welcome back. As most of you know, the purpose of this video is going to be to give you a very high level description of what my most recent refactor to the open-api Android app has been. So this app is, I think it's 2 years old by now. It's gone through a couple kind of major refactors. The last refactor I did on video, this refactor was like pretty much a rebuild of almost the whole app, at least from the back end sort of layer, like the views, the fragments, the activities, the view models, all of that stuff remained. Actually, never mind, not the view models. The view models changed also. Pretty much just the fragments, the activities, that the UI kind of layer is the only thing that really hasn't changed. Basically everything from view model and backwards. So view model, the repositories, the data sources, all that stuff has been now refactored, and I rebuilt it and really cleaned things up. And we're gonna kind of go through a very high level description of exactly what I did in this refactor. So actually on the open-api Android app source code page on GitHub, I did kind of a little bit of a readme description here of what the refactor actually was. So I'll just quickly kind of walk through this, and then I'm actually going to talk more specifically about what I did. So the first thing is I migrated from Dagger to Hilt. Hilt is great. Hilt is no longer in alpha and beta. It's it's fully released version. Hilt is awesome. It makes dependency injection way easier, especially on Android, because of the things that you get out of the box for the Android architecture component of view model. So you can do like constructor injection super easily and do a view model. You don't have to do that the map multi-bindings thing anymore. We can completely forget about that. It makes testing easier too, so it generates test components. Basically just makes everything way easier on Android. So if you're using an Android view model, or like an Android architecture components view model, Hilt is what you should be using. It's just way easier. So anyway, did the Hilt update. Next here is updated to navigation, or update navigation component. So now recently, within the last month or so, navigation component now supports multiple backstacks. So if you have that bottom navigation bar that most apps have, now it will maintain a backstack on each entry in the bottom navigation. Now that being said, I did do a video about this. I talked about kind of what I thought was great about it and what maybe it was missing a little bit. So I will hopefully remember to put a link up in one of these corners. I don't even remember which corner it goes up into. And you can see my sort of quote unquote review of the multiple backstacks thing. So check that out. But basically it's super simple. Like you update the navigation component version. We don't need that custom navigation controller thing that we were using before that would like save the nav host for each entry on the backstack. All that stuff is gone. You literally just update the version and it will maintain multiple backstacks. It's super easy. Next on my list here is decoupling. So in the previous iteration of the open-api app, I was sharing view models in a lot of the screens. So like, I think for all of the auth stuff, like login fragment, register fragment, launcher fragment, forgot password fragment, all 4 of those fragments, for example, were saving the same view model. The thing that was great about that was if you typed something into the login field and then said, oh, whoops, actually I want to register. You went to the register fragment and then decided, oh, whoops, actually I do want to log in. It didn't really matter because those fields would be saved because they were all sharing a view model. So obviously passing arguments back and forth between those fragments was super simple because they're sharing the same view model. There was also a couple other fragments that were doing that in the source code that were sharing a view model and just made like passing arguments super simple. I decided to get away from that, away from sharing view models, because when it came to testing, it's just way simpler to be able to test a fragment in isolation and not have to worry about the different state things that could be coming from different fragments. There's a little bit more code involved, obviously, because you have if you have 4 fragments and they're all sharing the same view model, that's they're sharing the same view model. It's way less code. But if you have 4 fragments each with their own view model, obviously there's going to be more code there. But the advantage is it's decoupled. No matter, that fragment can stand alone. It doesn't care about the other fragments. It's not getting any sort of state or arguments from the other fragments unless they're being passed as a bundle argument, which I'll probably talk more about that later. But it's a better, in my opinion, this is a better way to build it. So I got away from the sharing of view models. Now the rest of this stuff is, I think I'm just, actually here, let's just talk about these bottom 2 down here, this number 7 and number 8. Number 4, 5, 6, and 9, I'm going to talk about more in the video, and I'll show you examples, because if I just talk about it, unless you know clean architecture and like how I build out clean architecture, it's not going to make sense to you. So I'll just talk about number 7 and 8 here, and then we'll come back and talk about the other ones with examples. So number 7 is migrated from shared preferences to DataStore. That's, you know, obvious. That's the recommended way to kind of persist certain things across application launches. So just a pretty simple, straightforward migration to DataStore. DataStore is also great because you can emit flows from it. So like if you have whatever you have that's stored into DataStore, you can get it and it will get emitted as a flow. So as a suspend function. So like if you have it in your use cases, it will, you know, try and get that argument, wait, and then till it can proceed to the next line. So that's great because obviously, you know, everybody should be using coroutines, in my opinion. Everybody should be using suspend functions. They're great, and DataStore uses them, so awesome. Next is a migration from Kotlin synthetics to ViewBinding. So this is pretty much strictly just because if you go to Android Studio and you run your app and you're using Kotlin synthetics to, you know, you don't have to use find view by ID anymore. Basically, that's what Kotlin synthetics did. It made you able to create like this reference to whatever ID that view component had. So they've been deprecated. So I just, you know, did the migration to ViewBinding, which is what Android Studio will tell you to do. You'll get a little warning down your bottom left-hand corner, down where your little run thing is, and it will tell you to migrate to ViewBinding. Pretty straightforward. It's not complicated. So those are the ones that I'm going to talk about at the beginning. And now let's talk about number 4, number 5, number 6, and number 9. And this is pretty much the kind of complete refactoring of the whole back end of the architecture that I was talking about in the beginning of the video. Actually, before we actually start talking about it, I just want to say that if you don't know what clean architecture is, if you've never used clean architecture on Android, you've never watched my clean architecture course, you've never watched my Kotlin multi-platform course, which is also using clean architecture, this stuff will be a little confusing to you because I'm going at a very high level here. My goal is not to teach you clean architecture in this video. It's just to tell you how I refactored the course or the code. So if you don't understand clean architecture, you want to know more, which I suggest you should understand clean architecture, because if you want to get a job, they probably expect you to understand clean architecture principles. Go watch my course on clean architecture. Go watch my course on Kotlin multi-platform. If you don't have a Mac, it doesn't matter. You can still build the entire Android client for the Kotlin multi-platform app, which is like probably 80 to 90% of the course, and you understand you'll learn clean architecture in that too. That's a better course, honestly. Like if you're trying to choose, like if you know you want to learn clean architecture, you don't know if you want to take the clean architecture course or the Kotlin multi-platform course, take the Kotlin multi-platform course. It's a better course. It uses Jetpack Compose. It's great. Go check it out. Okay, so let's take a look at an architecture diagram first of all. So like I said, the entire kind of back end of the architecture of the app is really the big kind of rebuild of this refactor. So now we have this sort of structure. We have like our domain models, which is our core business models. We have a data source sort of section where we have our different data sources, which for us, that's going to be the room persistence library for the caching, retrofit for the network. And then we have interactors, and these are the use cases. Now, if you don't know what use cases are, I should probably explain that a little better for you. Okay, so here I have the sort of auth level, I guess, architecture of the app. We have like auth activity here at the top, and inside auth activity is launcher fragment, forgot password fragment, login fragment, and register fragment. This is the same structure as we had before the refactor, so nothing should be kind of surprising here. So launcher fragment has no view model. Forgot password fragment has forgot password view model. That's this right here. Login fragment has login view model, and register fragment has register view model. Now, like I said earlier too, when I was talking about the refactor, I got rid of the sharing of view models. So these 4 fragments used to share view models, now they all have their own sort of view model. So each one of these fragments is a little different. Forgot password fragment, for example, that accesses a web view. So if you remember watching the open-api course, that uses a web view that actually accesses open-api.xyz to send a password reset link. Login fragment has login view model, and here's where we're going to start talking about use cases. So the use case that can be executed in login fragment is the login use case. So that's this one right here. And then the use case that can be executed in the register fragment or the register view model is the register use case. So now you have a question, I'm sure, and that question is, well, what the hell is a use case? Because before what we had was we had our view models, and then we just had kind of all of the logic inside of the view model, or actually, never mind, it was the repository pattern. So I had like an auth repository, and then inside that auth repository, there was like all of the things that could happen in that auth view model. So basically, I guess you would think of a use case as the functions that used to be in the repository. So essentially you've kind of broken it apart. Before it used to be like, one repository where it had all the functions that could happen in that auth sort of section of the app. Now each of those functions is broken apart. So you essentially have a more isolated system that you can test. And we'll talk more about those use cases. Okay, so what is a use case? What does it mean to be a use case? What is this? If you don't know what clean architecture is, let's just talk quickly about what a use case is. So essentially a use case, let's start with this. Let's start with this. A use case is something that executes a set of business logic. So let's go business logic. There's a set of business logic that the use case is responsible for executing. So what kind of things does a use case need to function correctly? Well, in our case, we have two things. There's going to be a caching data source for our use cases, and not every use case can have a caching data source and also a network data source. So that's the other one that I'm going to draw over here. Oh, that was really terrible writing. Let's just get rid of that. So a network data source. So a use case has arguments. What are those arguments? It can be a network data source and also a caching data source. And you could have multiple caching data sources. You could have multiple network data sources. The point of this is just they are arguments. They're things that a use case gets its data from or sends data to. So for us, the caching data source is the room persistence library, as I talked about in the diagram. The network data source is retrofit. So that's the REST framework that I set up on open-api.xyz. So now that you've seen kind of what the structure, the high level structure is going to be like, maybe let's just take a look at the code. So right away, when you open the project, you'll see the package structure is very different. You have sort of these three high level packages: business, DI for dependency injection, and then presentation. DI is pretty obvious. That's just like your dependency injection, your Dagger modules, your Hilt modules. So I'm gonna just pretend that doesn't exist for now because I think it's pretty obvious. The other two are business and presentation. So if you take a look at the diagram that I showed you earlier, we have two kind of main separators in this clean architecture diagram: business and framework. So that's the two layers of separation we have here. We have business and then framework, which I just named presentation. So inside presentation is all of the UI stuff. So like in auth, you have auth activity, then all of the fragments that are associated with that auth activity. So if I open up, forgot password, we have forgot password fragment, we have the events that can happen in that screen, we have the state for that screen, and then we have the view model. And each one of these has the same thing. Launchers is an exception because nothing happens there, but login will have the same. So login events, login fragment, login state, login view model. Register is register events, register fragment, register state, register view model. I think you get the idea here. So that's kind of the main setup for the UI stuff. We have auth, which is the same as we had before the refactor, or the same kind of separation anyway. And then we have main, which has main activity, the account stuff, which is then broken up into three more packages. So each one of these has their own, events, fragments, state, and view model. Again, events, fragments, state, and view model. This pattern goes on and on through the code. It's all the same. It makes testing these fragments super easy because they can exist in isolation. They don't depend on anything else. And then we have that kind of special case, which is the session package. So we have our session manager, then we have session events and session state. So if you recall from sort of before the refactor, we had a session manager before, but we didn't have session events and session state. So I've sort of improved upon that. Essentially, the session manager, you can think of it as a application level view model. That's pretty much what it is. It's a singleton. It exists as long as the app is alive. It handles sort of what happens when you want to log in, what happens when you want to log out. All of that stuff has to happen at the highest level possible, because if a user is logged out, they don't have access to the app. So it's pretty obvious that has to be at the top. So yeah, like I said, the UI stuff, like everything in presentation, hasn't changed that much, other than cleaning things up, and then obviously no more sharing of view models, but pretty similar. And then of course, actually, sorry, I did create a bunch of new classes. Like each one of these fragments has events. So this is something you wouldn't have seen before if you've never watched my clean architecture course or anything. So each screen has a Kotlin sealed class that defines what events can happen in that screen. So forgot password fragment, for example, can have like Okay, send a reset link. What happens if there's an error? What happens if you want to remove a message from the queue, which we'll talk more about that. Maybe I'll go to another example. Let's go to the blog. Let's go to the blog list screen. So what can happen in the blog list screen? Well, you can just go take a look at the blog events. We can have a new search. We can do pagination. So going to the next page, updating the query. So like that's when somebody types in the search bar, they update that search query. Updating the filter. So that means, ascending or descending order, filtering on the date, filtering on the author. That's, updating the filter. Actually I broke that up into two things. So the filter is like whether you want to filter on the author or the date, and then order is ascending or descending. And I created these kind of utility classes to package all that up nicely. Get filter and order, or get order and filter, that's accessing DataStore, fires off a use case. I think you get the idea. Basically just the events that can happen in that screen. And then the view model for that screen, so let's go into blog view model. It captures all of those events. So it has this on trigger event function where you have those blog events being passed in, and then it just checks for what event that is. So if it's the new search event, you execute the search function. If it's the next page event, you execute the next page function, and so on and so on. The respective event calls a specific function. So now what about use cases? So as I said, each view model has use cases that it's capable of executing. So these use cases are just classes. I'll show one to you in just a second. And then those use cases are passed as arguments to the view model. So the only two that are actually use cases are search blogs and get order and filter. So these are two use cases that are possible to be executed in the blog list screen. So let's just go down to on trigger events. So like, for example, the new search event is fired. It would fire off the search function. Let's go down and look for that search function. Here it is here. So what happens when the search function gets called? Well, we want to reset the page number. So set page, whatever the page is, to 1 because it's a brand new search. We want to clear the current list of data, and then we want to execute that use case. And then we listen for the emissions from that use case. So if we want to get the loading state, like whether the progress bar shows or hides while that use case is being executed. If there's data returned, we get that data. And then if there's an error, we get the error. Pretty straightforward. Basically, every view model, every use case execution looks exactly like this. It emits a flow. So you just listen to the flow, you get data state coming in, you then set the data state based on what you get from that flow. So let's go to the use case. Let's go to one example of a use case just so you can take a look and see what this looks like. And again, if you have not watched my clean architecture course, or you have never heard of clean architecture, you're really just this is gonna be very confusing to you. So I really highly suggest that if you don't know, you should go watch either my clean architecture course or even better, my KMM course. And again, if you don't have a Mac, it doesn't matter. You can still build the entire Android client. Basically, the only thing that you won't be able to do is build that final Mac UI, which it doesn't matter at all. And yeah, just, I take you through that course and I teach you clean architecture if you don't know it, or watch the clean architecture course. It's up to you, but I think the KMM one is better. If you do that and you come back and watch this video, or just look at the code on Git, go to the open-api app, look at the code on Git, you'll have a huge aha moment. You'll just look at the code and you'll very clearly see, oh, it's clean architecture. I see. Here's the UI. Here's the data sources. Here's the use cases. Here's the view models. I understand everything that Mitch did now. Perfect. So, I suggest doing that. All right, so here we have the search blogs use case. So what happens here? Well, when I build a use case, I try to build them as similar as possible. Like I follow the same sort of pattern so they look generally the same. They'll have a custom name. So like this one's called search blogs, but they all have a function called execute. Now the execute function differs from use case to use case with respect to their arguments, but I like to call it execute every time just to keep things, as similar as possible. So what do I need for this search blogs use case? Well, like I said in my earlier diagram where I showed you what is a use case, it takes data sources. So here's your network data source, here's your caching data source, and then the execute function also requires arguments. So we need the authentication token if we're gonna hit the network, hit the API. We need to know what the search query is. We need to know what the page number is. The filter, so ascending, descending, that kind of thing. The filter is date updated or author. The order is ascending or descending. And then we have a flow that's being emitted. Now, I honestly can't remember if I had flows in the repository before the refactor. I think I did when I did the flows and channels refactor. But again, if you don't understand what's happening here, it's pretty simple. You just have a flow. So it's a Kotlin flow that is going to be emitting some kind of state. So I have data state that's wrapping around a specific data type. So this is a search blogs use case. So we're going to be getting a list of blogs from the API. That's why it's returning a list of blogs. It's wrapping around the data state. First thing you do in every use case is you emit the loading state. That tells the UI, okay, time to show the progress bar. And then you execute the business logic for this use case. So you can see a bunch of stuff is in here. Like the first thing we're checking here is if the auth token is null. If it's null, I want to throw an exception. And what will happen when I throw an exception? Well, if I scroll down, there is a try catch block. If there's an exception thrown, it will then emit an error specific to that particular use case. So you could have, got the message from the use case. Like I could have gone, e.message or got the error from the exception it was thrown, but I just want to keep it simple. And I just said, anytime there's an exception thrown, just say unable to update the cache. Actually, now that I think about it, that's the wrong exception. That top level exception that is being thrown up here, if the auth token is null, is not actually part of that try catch. It gets caught down here in this catch, which will call this function handle a use case exception, which just emits an error. So you can see here, it's going to emit an error based on some response, or right here, the message from that exception. So take a look at that if you want to kind of dig deeper into that. But essentially, all you need to know here is inside this use case, it's a set of logic specific to this particular thing that I'm trying to do. And the particular thing that I'm trying to do here is just get some blog posts from the network. So when you're getting blog posts from the network, first thing is obviously try and get them from the network. So that's what this is doing right here. If I'm able to get them from the network, I want to cache them. So there they are being cached. And if all of that is all good, then I want to emit from the cache, which is what's happening here. So it's kind of three things. You get the blogs from the network, insert or update the cache, and then emit them from the cache once they've been inserted. And that's one example of a use case. You can see that there's multiple things happening in here. You're handling exceptions, you're looking for specific error cases, you're getting network data, you're inserting into the cache, you're emitting from the cache. It's everything that needs to happen in that use case. That's what's beautiful about these. And then they're very easy to unit test because you have a set of logic that you need to confirm happens, basically. And I also wrote unit tests in the refactor, and let's go take a look at a unit test now. So since we just looked at the search blogs use case, let's look at the search blogs unit test. So go down to the test package down here. You can see there's data sources and there's interactors. All of the actual unit tests are in interactors. Data source is just the sort of fakes, or the fake data sets, basically, because in a unit test, you're obviously not actually hitting the network, you're not actually hitting the cache, so you build fake versions of those data sources when you're doing your unit test. Let's go take a look. So go into the blog section here, and if we go to search blogs test, let's see what this looks like. So there's 6 tests inside of this class. There's 3 success cases and 3 failure cases. So the success cases are retrieve 10 blog posts, retrieve 3 blog posts, and then retrieve an empty list. So what you want to do is you want to just confirm that if the use case returns, does it get 10 blog posts from the fake data source? Does it insert them into the fake cache, and then does it emit them? That's really the things that you're testing, and then make sure that no exceptions are thrown. Then for this one, same thing except with 3. And then this one is you want to test to make sure that, in the event that an empty list is returned from the network, that everything doesn't break. You still insert nothing into the cache because there's nothing got retrieved from the network. It emits nothing because nothing was retrieved. That's kind of the things that you look at. Then you have a bunch of failure cases. So I don't want to talk about each one of these tests. Let's just go through one of them. So let's look at the first success case, retrieve 10 blog posts. So scroll down and let's look at this one. So I called it success 10 blogs. So because I'm using retrofit, I used mock web server to set up a fake sort of network data source. Mock web server is really great, although there's also other third-party libraries that are just as good. Like if you're using Ktor, there's, I can't remember what I was using. I was using something the other day and it does pretty much exactly the same thing. But anyway, what it allows you to do is set up like a fake HTTP response. So I'm saying make sure that it's successful and then return this data when a request is made. So what is this data? This is just the same data that would have been returned from a successful network operation if it hit the network. So I'm returning like literally JSON data. I don't know why it's not, there we go. So search blogs, responses, and I have here success 10 blogs, and it's literally JSON data, the exact same JSON data that would be returned from the API if there was a successful response. So yeah, let's look at what else happens here. So this is kind of the setup stuff. We get the auth token. We want to first confirm that there are no blogs in the cache because we're starting from blank slate here, right? We have a fake cache, we have a fake network data source. The first thing you want to do is check that the cache is empty, because in this use case that we're executing, we're going to get 10 from the cache. We're going to insert them into we're going to get 10 from the network, sorry. We're going to insert them into the cache. Then we want to emit them from the cache. So in order to confirm that it's working correctly, we have to confirm that the cache was empty to begin with, because if we just check after we get it from the network and after we insert it into the cache, we don't know what was in the cache to begin with. So we want to make sure that we have a good baseline. We confirm the cache is empty. Now let's execute the use case and see if it does what it's supposed to. So no blogs in the cache, great. Now let's execute that use case. So for that, if you're testing a flow, they have a couple of really handy functions that they have. One of them is toList. So what this will do is it will, you execute the use case and you call toList on it, and it will break up all of the flow emissions into a list. So for example, the first emission, if we look at our use case and scroll up to the top here, the first emission is going to be loading. So that's what we check. We say, okay, is that first emission loading? And assert that that's true. If that's true, then we move on. Second, we want to make sure that the blogs were inserted into the cache. So if we look here, we scroll down, it's going to execute that network operation. It's going to get that data, and then it's going to insert it into the cache. So we want to confirm that that did happen. So what we can do is just query the cache and confirm that the size is 10. Because remember, at the beginning, before the use case was executed, we confirmed that the cache is empty. So if we know that if now there is 10 items in that cache, we know that the use case got the data from the network and inserted it into the cache. The next thing is confirming that the emissions are correct. So if we look at our use case, the next thing that happens here is we get the 10 cached blogs from the cache, and then we emit them to the view model. So we can check that here. So we're checking the second emission, checking that the data size of that list is 10, because remember we got 10 from the network. Make sure that the data in that list is not null. So like the fields in those objects are not null. And then we just confirm, or sorry, not the fields, we confirm that the objects are not null. And then we confirm that they're actually blog post objects. So technically you could have done this like 10 times because there's 10 entries, but I think one is fine. Like if one's a blog post, they're all going to be blog posts. So you just check one of them, make sure it's a blog post. That way you know, okay, the amount of data is correct. They're not null, they're blog posts. Probably everything worked correctly. And then the last thing is you want to check that the final emission is the loading state is now set to false. So you can see that my exclamation mark there is checking that this is false. And that's a successful use case. So there's the set of logic. We're making sure it works correctly, and that's a great unit test. Now the last thing I want to talk about, I actually don't want to talk about it anymore because this video is already 30 minutes, or it's probably close to 30 minutes, but we'll talk about it anyway because it's part of the refactor and I know that people are going to ask me about it. So if you watched the open-api course back in the day or whenever you watched it, you know that I used to have I think it was I called it a state message stack or something, or messaging stack or something. And if there was an error that happened somewhere in the view model or the repository, a message got added to that message stack, and then the UI looked at that stack, and that was how it knew to like show toast, dialogue, snack bars, all that stuff. So this kind of a system is something that I'm always trying to refine. I haven't seen the perfect implementation of this system ever. Yeah, I think it's not an easy problem to solve, like the problem of what happens when you have an error in a use case or an error somewhere. It doesn't matter where it is, view model, use case, UI, doesn't matter. What happens when an error occurs and you have to show something to the user, like a dialog, snack bar, toast, or capture input, all of these things. I'm yet to see a perfect solution to this problem. So my newest iteration of the solution to this problem, I added to this refactor. Now let's talk about that. So first of all, I realized that the messaging stack naming that I was using, specifically the stack naming, is not very good. So instead I created a queue. So I just like the Java queue, like if you go to the Oracle documentation, you look up a queue. I created a Kotlin version of that. So it has mostly the same functions, you know, like adding, removing, remove, element, peek, offer, poll, all that stuff. Everything that a queue should do. If you don't know what a queue is and you don't know the difference between a queue and a stack, a queue, they're basically opposites of one another. A queue is a first in, first out data structure. So if, say you have an error, you add it to the queue. So you have another error, you add it to the queue. The head of the queue is the one that was first in. That's why it's called a first in, first out data structure. So it makes much more sense for this sort of showing an error in the UI mechanism, because the first error that happens is the one that the user should see. It doesn't make sense that if there's 10 errors, the user would see the newest one first. The user should see the oldest one first. So a stack data structure is they would see the oldest one first, which doesn't make sense. So bad naming on my part, even though the functionality was correct in the previous open-api code. But anyway, so I've refactored that, created this queue, and now we have this queue. This queue data structure gets added to each state in each screen. So if we go to like the blog view model, for example, the state variable right here holds everything that the blog fragment needs to operate correctly. That's what we have, this mutable live data thing. So if I click on blog state, let's take a look and see what's in here. So we have loading. So that's like whether the progress bar should show, the blog list, the query page, is the query exhausted, filter, order. And then, so all this stuff should be pretty obvious to you. You should understand that. But then we have this queue thing down here. So the queue is how I just described it. It's a queue, and every time there's an error, whether it's in the view model, the use case, whatever, it gets added to that queue. And then basically in the fragments, it pretty much does exactly what it did before the refactor. If there's something in the queue, the UI will show the thing that's at the head of the queue. So if 3 errors are thrown, all 3 get added to the queue. The UI is, it's part of the state, so it's live data. It's going to show up immediately. When something's added to the queue, the thing at the head of the queue, the oldest thing gets shown. So if it's a dialogue, it will show that dialogue. The dialogue is only then removed from the queue when the user interacts with the dialogue. So like if a error dialogue shows up, in order to remove it from that queue, the user has to either click OK, cancel, or off of the dialogue. It will then get removed from the queue. If the user rotates the screen, nothing happens. The dialogue still shows because it hasn't been removed from that queue. So this is a pretty, it's a pretty reasonably good system. It checks all the boxes. If an error happens, the user sees it. If a rotation occurs or they send it to the background and come back, that error is still going to be there until they interact with it, and then it gets removed from the queue. So like I said, my system is not perfect. I'm constantly trying to refine this. Like I said, I have not seen a perfect implementation of this mechanism yet, because there's so many variables. There's like, you can have a toast, snack bar, you can have simply logging something. So like if an error happens, you don't always want to show it to the user. Maybe you'd want to send it to Crashlytics. Dialogues, what else is there? Notifications, maybe sometimes you want to show a notification. And each one of these things have different criteria. Like a dialogue has a title, a description, buttons, so it could have an OK button, a cancel button. Also, dialogues can capture input. A snack bar has a description, it can have a button. A toast has just text. Notification could have everything. So like there's a huge amount of flexibility with that. And so I haven't seen like the perfect system. Like I said, I think in the refactor, I think I only handled dialogues. Like I don't think I have, let me just look here, UI component type. Yeah, oh, no, never mind. I have toast dialogues and an are you sure dialogue, but easily more stuff could be added to that. So I don't want to talk more about it because it's just going to get into the weeds too much. So if you want to take a look at the code, go ahead. Or like I said, watch my clean architecture course. watch my KMM course. All right, we're almost done, ladies and gentlemen. If you've stuck around for this long, good job. You're insane, because I've probably been talking for at least 30 minutes for sure. The last thing I just want to talk about is real quick. I did some very minor updates to the server side responses. So like the stuff that you get when you make requests to the REST framework of the API. I just kind of cleaned things up a bit. Basically, you don't need to know anything. There's no changes that matter to you. You'll just get more meaningful responses when you have a failure on one of your use cases or one of your network operations. I could have honestly said nothing and you wouldn't have even known. But I thought I would mention it anyway. All right, boys and girls, that's gonna be it for the video. Hopefully it was helpful. I know this was a highly requested video, at least from the people in my Discord channel. You guys really wanted to see kind of a high level overview, at least, of this refactor. I'm assuming most of you have not watched the Clean Architecture course or haven't watched the KMM course, because I think if you did, it would be pretty obvious. Like if you watch those courses and you went to just look at the way I refactored it, you would say, oh, I see, he made it Clean Architecture. Great. And you would just understand. So that's I guess what I would finish with is, if you did not understand what I was talking about today, I highly recommend watching those courses. They're very good. They're my best courses by far. And if you're looking for a job in Android, or even if you're a solo developer, like, building things cleanly is going to save you time and pain. Having use cases that execute sets of business logic makes it more unit testable. Testing things in isolation, decoupling, all of these things are just great to know. And like I said, any job that you go to, if you show them these skills, they're gonna like them. Trust me, I know. I've talked to the people. These are the things that they look for. Actually, before I go, let's take a look at the app that I'm probably gonna be building my next course. Since you guys are crazy and you've stuck around this long, why wouldn't you stick around for another 2 minutes and take a look? So this isn't set in stone yet, but I'm thinking of doing a multi-module sort of clean architecture course. I mean, these days I'm going to build everything with clean architecture, so just assume it's going to be clean architecture at this point. So yeah, it's a multi-module. That's really the core thing here, though. So it's accessing a Dota 2 API, which is a computer game, if you guys didn't know what that is. And here it shows a list of the heroes. So these are like the guys that you could be. It's pretty simple. Like, there's some filtering up here. So if I and the filtering is in real time. So like if I filter, you can notice that the list is kind of filtering in real time. If I click this top button up here, there's some filter options. So if I want to filter on hero, Z to A to Z. Also notice the list is being updated in the background live as I'm clicking these things. We can filter on the win rates and then the primary attribute of that hero. So if I want to see strength heroes and I want to see the ones with the best win rate at the top, I would do that. Then there we go, and I could remove this text and see kind of the best win rate heroes at the top and the worst at the bottom. Yeah, so that's pretty much just this one screen. And then we have a detail screen. So if I click here, it tells you then the stats of these heroes. Basically just some information that you pull from the API. There's going to be, there's unit testing, clean architecture, MVI, Jetpack Compose, navigation component. I think I said unit tests already. Yeah, it's good. It's good. And if you think that multi-module stuff looks easy, it is relatively easy, but the thought process of how you plan out your modules is not simple, and it's not obvious at all what the best way to structure your modules are. Like, should you modularize by feature? Should you modularize by layer? Should you do some kind of a hybrid model? Should you, which is what we do, which I'll talk more about in the course, or what I'm going to do. So yeah, I mean, that information alone I think is probably the most valuable. But if you're interested in that, that's probably the course that I'm going to be building next. And I'm going to stop talking now because the video is probably 40 minutes. I've had enough. You've had enough. Let's get out of here. Don't forget your engagement.